Good evening, everyone. My name is Tass Skoudros. I'm the Managing Director for Servana. I'm also a software engineer and a DevOps engineer in time gone by. Servana is a DevOps specialist in Bournemouth. We help customers around the world deliver software. So on a day-to-day basis, we're building pipelines, we're helping developers solve some of the problems they have to get software to Japan, China, Europe. Today I want to talk about security. Security is a recurring theme in our work, and we thought it would be nice to share how we approach security with our customers. It's an important topic to them, it's important to us, and the approach that we've developed has taken a couple of years, and I'll breeze through it with you in 20 minutes. Security is a huge topic today. It's complicated at scale, and I think one of the biggest challenges facing development teams is being able to innovate and create software in a secure environment. With GDPR and regulation around storage and access to personal information, the requirements for security have increased. We believe this solution is to integrate security development into our projects, to make it a shared responsibility, and to use Agile processes to improve security features over time. Security development is good for a product team because the team is well organized to handle the threats and changes within an organization on a day-to-day basis. What I mean by this is, if you work in an Agile team, you know that you have your rituals every day, you have the processes which bring everyone together on a daily basis. And these are great forums for handling potential security issues, if you have any, which are urgent or not. The key here is security can't be outsourced. We don't think there is a scalable solution to outsourcing security to a team which isn't local to the development team, with your ops team, with the production of software. Security is important to every team member for 4 different reasons. We like to think that product owners like to promote security as one of the features which they're prioritizing. The delivery manager is looking for ways of ensuring there's always space within the daily plan to take care of any urgent security matters. The delivery manager also is a key part of making sure that security is on the backlog in the sprints, is part of the product development. And we have tech leads, and tech leads are, the way I look at it is every time we have a new infrastructure feature or a new thing, security has to be built at the same time. We don't do it retrospectively, it's always together. And the DevOps engineers today have a huge challenge, and we already had 2 talks today. And security was a big part of both of those conversations. I'll reference the first one where the talk was about handling of configurations within the pipelines, how they're encrypted. These are kind of best practices, and so it's really nice to see that that's something which is important and it's playing through. And our software engineers don't want to create bad code. They don't want to create insecure code. We think by using this model, we could short-circuit some of the bad practices which end up happening in a development process where security is a second thought. So more companies than ever before are building software. And with more software comes more threats. Things from sharing API keys, open source dependencies, and issues inside Docker containers. We had a very good example where We saw the GCP view, and they scan for security issues. What we've seen is that teams, when they typically begin developing, they probably start very small with a handful of people, and within a year or 2 years, if they're successful, they're doing 100 times more than they were in the beginning. And when you look at that in reality, you realize that security needs to be a part of that growth. You need to accept it in the very beginning to be able to scale with your software delivery. So we take an agile approach to security. The way we look at it is when a new project starts up, we have priorities, things which are very important for the life cycle of the project. Security is a broad topic, and I'm only touching on a few things specific to DevOps. And I think the key thing with this conversation is we're talking about security within the product team. So we're not talking about taking over security. It's very much about putting security where it counts. So I like to use the analogy that we layer security into our products. Basically, there's no single defense. Rather, we rely on having many different kinds of defenses. I've created a diagram to depict the kinds of work I think we need to do before teams reach their first milestone. So I've got first milestone down here. And most of this work is the kinds of stuff that we do in the first month to 6 months of a software project. The idea is simple. We begin building security from day one. Any aspect of security which we build becomes easier to improve as we move on into the software delivery lifecycle. So if you start with good access control, it'll be a lot easier to improve that as we progress. And likewise, all of these practices, if we sort of make a dent in them, we reduce the cost of delivering the security features in the long run. So before I go to the next slide, I just wanted to say there are a few principles which I think are quite important at this stage for an organization. Like, one of the things that we talk about is beginning with the end in mind. The reality is, in many cases, you have to know how you want to operate before you can start putting in your checks and balances within your infrastructure. And you do that from the very beginning. So in this life cycle, this is, say, five or 6 months later. The kinds of work we're doing here are handling alerts, monitoring deployments. We've got chat ops going. We've got changes happening in a live environment. And at the same time, we're probably making changes to all of the little things we made changes to before, which is something you can only do if you begin with the end in mind. It's cheaper to implement security at this point in time. It will never get cheaper. So the first thing that I wanted to start with is access control. The idea is to make security a part of our agile planning process. Security in the beginning is all about access control. It is a critical place to start. Most vulnerabilities come from inadequate access controls and a proliferation of shared API keys. Consider all software and DevOps engineers that have committed API keys into public repos. A key mention at this point is the two fundamental strategies we implement: a role-based access control across the board and multi-factor authentication. And I've sort of done it like a Jira, like a planning session. You take Post-its and you put tasks down. So just to give you a feel for how it works. So I thought with access control, let's talk about a time in the past where access control didn't work. Uber was hacked because they put API keys into an S3 bucket, which hackers found and then stole the information of their customers and drivers, including driver's license numbers and everything. They paid the hackers 100 grand to keep quiet and walked away from it, and the whole issue came back at some point in the future. Recently, we had an issue with Kubernetes. So people who were using the Kubernetes dashboard had privileged information leak, which gave hackers control of their Kubernetes clusters. The hackers they had root access to Kubernetes clusters. Again, access control issues, which probably could have been dealt with quite easily from day one and weren't done. So that the CICD platform combines a variety of purposes into one system. We already saw an example of one in the first conversation. We spend a lot of time making sure the CICD platform is secure. The reason why it's one of our core areas to focus on is because of how it combines a variety of purposes into one system that, without the right configuration, can create a number of vulnerabilities around privilege escalation and leaking information. So avoid the CI/CD platform becoming a source for vulnerabilities by setting up correctly a few simple rules. So we use a principle called the principle of least privilege on agents. We also use a concept called the separation of concern to ring fence permissions on agents. What this means is when we're giving agents or permissions on our platform, we ensure that they can only be used for the purpose that they're used for. And the way we would do this is with a role, by giving the agent a role which has limited permissions. Again, role-based access control. And we also integrate approval workflows into pipelines, also another important step. So the next stage is infrastructure configuration. A big part of the DevOps engineer's life is automation. And while a project is progressing, we'll need to keep ahead of infrastructure level security. Again, we use a similar concept of role-based access control, separation of concern, and principle of least privilege. In the example, I've made a reference to a few examples. So we have a queuing system plan on the right. One of the things about infrastructure which is interesting is, in many cases, you consider infrastructure without considering the application you're trying to run. And in our case, we have almost a separate strategy for application security, which leverages a similar pattern, but we handle it as part of the application development, not as part of infrastructure configuration. So in slightly different places. Again, some examples of organizations which were hit because they didn't pay enough attention to their infrastructure. So matrix.org had an issue with their SSL implementation, which was exploited. The hackers managed to gain access to their entire cluster, causing all kinds of damage. Another really good example is Kibana. So I don't know if people use Elasticsearch and Kibana. There was another incident recently where people hadn't put an IP whitelist. So Kibana doesn't actually have authentication built in. And a lot of strategies use IP whitelisting. So you tell Kibana only people from this IP can access the server. A lot of people didn't know that, and they had Kibanas on the public internet with leaking private information of their customers. So another example of where if you start security early, you can make improvements which yield returns in the long run. So the principle of least privilege, I think in practice, this means that there should be no privileged users in your environments. Rather, to perform an action, the user needs to use a role or become a role, needs to use a role. And the same concept applies to application security. The way we handle application security is we only give applications the necessary privileges to perform their duties. In the example where we had a queuing system, they would have access to just put messages onto the queue. And then we have the separation of concern, which is a strategy where we have a role and we have permission, but how granular should the permission be? In my experience, the more granular, the better. But it's best to follow functional responsibilities. In practice, this will mean I'd be looking to make sure that we isolate roles based on teams and the microservice and the environment. So part of the reason why I wanted to put a talk like this together was because once you get to production, security is about risk management. It's not obvious, but once you get to the end of your development life cycle, to the bottom of the base of the triangle, your security is about risk management. In many cases, you'll have issues which you know are vulnerabilities. You can't do anything about it. And that's why we believe and insist that we layer security into our work. As a team, as a product team, it's important that at the end, you are able to deal with the influx of threats and vulnerabilities easily. This will mean making sure that your change process has the ability to handle emergency changes. I'd also recommend using OWASP scans in the pipeline for dependencies, regular container scans, and to keep up to date with security patches. So we have a number of other best practices which use a WAF, do frequent audits, use multi-factor authentication, IP whitelisting, and enforce header security. Encrypt all secrets for all environments. Any questions?
I'm going to ask those questions today. So how do you protect the CICD pipeline? Because I've always thought, Jenkins, GitLab, if I was going to attack an organisation, I'd go after Jenkins. It has generally access to everything. And a service account stored there. It feels like you get administrative access to Jenkins, you've got golden keys to everything. What are your recommendations in that regard?
So I actually had some notes. I'll just go back to the slide because I used CICD as an example in the separation of concern. So I would, the advice would be, first of all, never have an agent that can do more than one thing. Okay? So, and the reason why is because what you want is for the agent that you configure to only be able to do a minimum role within your pipelines. So the way we look at it is we have like a test agent, a build agent, configuration agent, a decryption agent. So we don't ever, when we use Jenkins, we don't ever have a Jenkins that can do both. It just doesn't make sense. And if we do, they're going to have different keys and different roles and different. It is a bit more complicated, which is why we like to layer it. We start from the beginning.
No, it's good to see, yeah.
And we work our way down. But it isn't less. It's just more configuration, more understanding the concept. So in our case, Jenkins should not be root. Like we're actually CloudBees partners, and we're European Jenkins support partners as well, and so we kind of deal with this kind of work often. And in our case, the advice is always to do the best you can on your configuration, to avoid creating a super user, a super agent, to use role-based access control in Jenkins. It's possible to configure your agents so that they only do a single task. They're only build agents. They're only test agents, and that's important. So, in the very beginning, I kind of said security is broad. It's pretty immense, because it's crazy how when you get into security, you realize there's a lot to it. And I'll just put one example to you now. So, let's go back to the slide. I need to jog my memory quick. So, it was this slide that I was thinking of. Okay. So the reason why is because the threats come from everywhere today. So the one threat that we deal with enough, because we have a lot of customers that use open source tools in Node.js or in PHP or in some of the open source tools which are less secured. I mean, Node.js is 100 times better today than it was 2 years ago. But obviously, we still have the experience from 2 years ago. So for us, it's like we know we need to be resilient with our security. And the reason why I pointed that out specifically was because in the example you had with the agents and Jenkins, one of the big threats that we have is when people use Node.js for exploits. So for example, in your test lifecycle, you will download some dependencies which are deliberately trying to run within the test lifecycle. People know this specific tool is used in test, this specific tool is used in build. And they know that when they're in the build, on the build agent, they have access to potentially production. So you download your Node dependencies and you run your test, and they basically can hotwire themselves into the tool chain and execute from inside your network. So once you know that, you're like, okay, right, so we have a challenge. The challenge is basically we can't trust what's inside and what's outside. And so we sort of want to layer security everywhere. We want to use it on the agents. We want to use it to lock down Jenkins, prevent Jenkins becoming root. Have I answered the question?
No, that's good. It's good to see that level of rigor. Yeah.
Any other questions?
Just a quick question from a recruitment perspective, because obviously we recruit for you guys. We're seeing it more prominent. There's like DevSecOps as a job title. Do you think that's going to be like alleviated in the future and everyone just have that kind of thinking? Is that like the end goal? Or?
I believe so. So I think that security has to be part of the product. I don't think. I think when you think about DevSecOps, you need to think about the product and how organizations create teams. So it's like you'll get a product team which will be responsible for a service, and they'll have the responsibility to handle security. They'll probably deal with a proxy within the organization on security matters. That's sort of what I think will happen. It's what happened with DevOps, with the operations. Yeah, but I don't know if there'll be a role where there'll be someone who's in charge of security within a product team. I sort of believe, and it's one interesting thing, you find with DevOps, you're kind of doing you're wearing many hats. You're like infrastructure, CICD, you're doing security, you're doing all kinds of things. You're building pipelines, building configuration. It's like a very interesting career, and I think security is on par with that. But I think it might be something that is done by the DevOps engineer or by the developers as well.
Any more questions?
Yeah, please. How do you make, from what is it's like you've got a team of people, but if you was doing a racing matrix, how do you then do that? Say, here's the person that is responsible for security.
There isn't a person.
But
The team.
Is that a threat to your business?
Well, the team is responsible for security.
No, who's accountable? You can't have a team. Someone who has responsibility.
I believe, okay, so it's interesting you mentioned that.
A team forming a product, developing a service.
Agree.
So if your company gets sued by someone else,
So
what do you then
no
do?
one here is the CISO. No one here is the security architect, or these are people who are dealing with the local aspects of security. The reason why I think the model works really well is because these people, through the product owner will probably do like a report to say, we spent 400 man hours on security this month. These are the things we did. And the CISO will be like, okay, this product team is making progress on security. And maybe the architect will be interested in the kind of work they're doing. What kind of work are you doing? Role-based access control, encrypting secrets, encrypting storage at rest, things like that.
So you're kind of like saying that between all of those people, you form, say you've got a regulatory requirement somewhere, between all of those people, you're making sure it's fulfilled. Yeah, but no one individual is personally in the position to say that can go out.
I think so I think you're right. I think there will always be someone who is in charge of security. And there will be a senior person within the organization. The bit which I haven't said, which I probably should say, is I don't think you can outsource security anymore. So you couldn't have a security team in Block B who are in charge of dealing with your security. This is the model which is a sustainable model for building software